Hello and welcome to today's video on equivalent or congruent modulo. This is Mr. Alfred Gordon. Before we begin with that, let us try these examples on finding modulos of some given numbers. So let's try this example. So first, try 16 mod 5. Okay, and let's also try 31 mod 5. Okay, now looking at these two examples, we know that for 16 mod 5, we can either use repeated subtraction or use the division method to determine the mode. So from our previous videos, we can see that 16 mod 5 will give us a result of 1, and then for 31 mod 5 will also give us a result of 1. Okay, so what can we see here? Now we can see that both evaluations, okay, of 16 mod 5 and 31 mod 5 results in the same remainder. So we can see that then the remainder we are getting for 16 mod 5, okay, is equivalent to the results we are getting for 31 mod 5. Okay, now which can be written as, then we can see that 16 is equivalent to 31 mod 5. Now this expression here tells us about two moduli that are equivalent. So in general, when we say A is equivalent to B mod n, okay, now this tells us that then when we have an integer A mod n, its result is equivalent to an integer B mod n. That is about equivalent moduli. So let's try some examples. Now let's determine whether the following are equivalent. So I will say that determine whether or not the following are equivalent. Now we have 13 is equivalent to 5 mod 4. Okay, we know that for equivalency, 13 mod 4, okay, from our previous videos, you can do a repeated subtraction. Okay, so for repeated subtraction, we have 13 minus 4 to give us a 9, and 9 minus 4 to give us a 5, and a 5 minus 4 to give us 1. Okay, so 13 mod 4 gives us 1. Also, for 5 mod 4, now for 5 mod 4, we can do 5 minus 4 and we have 1, and this is also 1. So what can we see here? Now we can see that 13 mod 4 gives us a remainder of 1, whilst 5 mod 4 also gives us a result of 1. Therefore, we can conclude by saying that it is true that 13 is equivalent to 5 mod 4. So this is really true. Now let's come to the second example. Now with the second example, we are told that 17 is equivalent to 12 mod 3. Now we are not sure of whether they are really equivalent or not. Okay, so we can begin by doing a 17 mod 3 and 17 mod 3 with repeated subtraction. We do 17 minus 3 to give us a 14. We can go ahead to do a 14 minus a 3 to give us 11. We can do 11 minus 3 to give us 8. Okay, I'm sure. And then 8 minus 3 to give us 5. And then a 5 minus 3 to give us a 2. Now we know subtracting 3 again will give us a negative, so our result here is nothing but a 2. Okay, but for 12 mode 3, we can do 12 minus 3 to give us a 9, and 9 minus 3 to give us 6, 6 minus 3 to give us 3, and 3 minus 3 to give us 0. So 12 mod 3 is 0. Now what can we say about this? Now we could see that for 17 mod 3 we have a remainder of 2, and for 12 mod 3 we have a remainder of 0. Therefore, the statement we have here is really false. They are not equivalent. Okay,